The next section we're going to do is 2.2, factors and prime factorization. So the first example that we have here says, list all the factors of the first number is 18. So what that means, what we want to do is we want to find all the numbers that multiply to 18. So, well, I know 1 and 18 multiply to 18. I also know that 2 and 9 multiply to 18. And I also know that 3 and 6 multiply to 18. So there's the list of numbers that all multiply to 18. Okay, for 25, well, I know that 1 and 25 multiply to 25, as well as 5 and 5. Now, since I'm just listing the factors, I don't need to list the number 5 twice. It's just I know that 5 is a factor of 25. Now, for 37, if we think about that for a moment, 37, what are the numbers that multiply to 37? If you take a look at your multiplication table, or if you go to Google and search for a multiplication table, you'll notice that the only numbers that multiply to 37 are 1 and 37. This leads us to the next part, prime numbers. Prime numbers are numbers that it can only be expressed as a product of itself and 1. So I'm going to give you a list of prime numbers. Numbers that are prime are 2, let me get my pen back, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, and 43. Now that's a list of prime numbers. I want you to think about those numbers for a minute. Those numbers, the only numbers that multiply to 2 are 1 and 2. The only numbers that multiply to 3 are 1 and 3. The only numbers that multiply to 5 are 1 and 5. So on and so forth. You can't break down numbers like 11 and 13 and 17 other than itself and 1. So this is what we call prime numbers. So the next part that I have here says, let's find the prime factorization of each of these numbers. The prime factorization means we want to break these numbers down until we can't break them down anymore. So I'm going to show you a couple of ways we can do this. One way is we can do what we call a tree. So what two numbers might multiply to 56? Some people might say, well, 7 and 8. Okay, well now, can I break up the number 8? Yes, I can. 8 is 2 times 4. Can I break up the number 4? Yes, we can. That's 2 and 2. Now, I can't break any of these numbers down anymore. So what I'm going to do is I'm going to circle my prime numbers. 7 is prime, 2 is prime, 2 is prime, and this 2 is prime. So when I'm going to write out my prime factorization, I'm going to say, well, this is 2 to the third power times 7. I want you to notice I'm not using my numbers 8 and 4 because I was able to break those numbers down. I'm going to go ahead and do the same thing for my number 75. So 75, well, I know that's 3 and 25. 25 I know is 5 and 5. Now again, remember, I'm only looking for my prime numbers. So 75 would be 3 times 5 squared. For a number like 242, what I might do here is I might take my number 242, let me get my pen, okay, I'm going to divide it by 2. So 2 goes into 142 121 times. Now, I know I can break up 121 by 11 and 11. This is what we call a factor ladder, because they kind of look like little ladders here. And so now I can't break down 11 anymore, so my answer is 2 times 11 squared. I'll go ahead and do the same thing for my number 162. So 162, the number is even, so I know I can divide it by 2. So that's going to give me 2 and 81. Now 81 is a number that, I think I know it pretty well just because I've seen my multiplication table many times. So 81 I know is 9 times 9, And each of those 9s breaks down into 3 times 3. So my final answer is going to be 2 times 3 to the power 4.